Right, so we are on class A, and most people coming into our pre-16, pre-17 class have seen the lines and parabolas from their previous class, but I want to make sure that we're all kind of coming from exactly the same place in terms of what we remember. So we're going to start with equations of lines. And so I know the one that at least the Math D group that I was working with last quarter, we decided that we liked the best was our slope-intercept form for the equation of the line. And so that's the y equals mx plus b form. And when we have it written in that form, what we know is that we've got the m representing the slope. And we have the b representing our y-intercept for the line. And so that's why this one's called the slope-intercept form. And then we have other forms for equation of lines that we can either use in certain circumstances or that we might see in other situations, and we need to be able to recognize that it's still a line. So point slope is the second one that you'll see often. So that's when we have the y minus y sub 1 is equal to m times the quantity x minus x of 1. And when we have our equation of the line written in this form, the point is at the coordinates x1 comma y1. And so this one's called point slope form. Okay. And so both of them are useful in different situations. Typically, when we're graphing, the one that we like to use is the slope-intercept form. But there are situations when we're writing equations of lines where using the point slope form sometimes people prefer. So we're going to look at an example where we're going to graph the following lines and then label the x and y intercepts. And so the y-intercept for the equation of a line is where the line is crossing on the y-axis. So in order to find a y-intercept, because that's where we're crossing on the y-axis, and the y-axis is the one that goes up and down, when you're on a coordinate plane, your y-axis, this one right here, is always where your x value is equal to 0. So to find the y-intercept of the equation of a line, you plug in x equals 0 and solve for y. And to find the x-intercepts for a line or parabola or whatever we're talking about, this is our x-axis. And so the x-intercepts are going to occur when your y value is at 0. So to find x-intercepts, you plug in y equals 0 and solve for x. So what we're going to do is we're going to graph the first equation, y is equal to 2x minus 4, by first identifying our slope and our y-intercept. So I can see that I have a slope of 2. My m is equal to 2. And so some of you might prefer to write it as 2 over 1 so that you can see the rise over the run. And we have a y-intercept of -4. So the b value is -4 for that first line. And so I'm going to go ahead and graph that line in blue. And what we always do when we're graphing the equation of a line, if we have the slope and we have the y-intercept, we go ahead and put the y-intercept on our y-axis first. So our y-intercept is -4. So I'm coming down here to -4. I'm going to go ahead and just put that on my coordinate plane. And then from there, you're going to go ahead and use your slope. Your rise is 2, your run is +1. So from your -4, you're going to go up 2 and over to the right 1. And that's going to give you 2 points. And with 2 points, you can actually go ahead and just connect the dots and make a line. But if you want to have some more points to make sure that you've got your line as accurate as possible, from any point, if you go up 2 and then over to the right 1, that'll give you another point on your line. So you can keep doing that if you want, up 2 and over to the right 1. Now I've got 4 dots on the same line. So I can go ahead and connect them. You only need to do 2, but I'm just showing you that you can get additional ones. And so we're going to go ahead and just connect those. And that's the equation of our line, y is equal to 2x minus 4. So now we're going to go ahead and we're going to graph the second line on the same coordinate plane. And for this one, we have a slope of -3/2. And you can put that negative sign either with a 3 or with a 2. It doesn't matter. They're both equivalent to each other. So you could write that the slope is -3 over +2, or you could write that the slope is +3 over -2, which would change how you were going to do your rise over run, but I can show you that that's not going to matter. This one, you would be going down 3 and then over to the right 2. Or if you use this way, you're going to go up 3 and then backwards 2 units or to the left 2. But that's going to end up giving us points that are on the same line. And our y-intercept for this line, our b, is equal to +4. And so I'm going to go ahead and come up to +4 on my y-axis. And put my first point down. And then I'll show you how we can either use the -3 over +2 or +3 over -2, and we're still going to get points on the same line. So first, I'm going to go ahead and use my rise of -3. So I'm going to go down 3, and then I'm going to go over to the right 2 units. And so that would put my second point right here. But if instead I decided to use +3 over -2, from that 4, my y-intercept, I would have gone up 3, but then backwards or to the left 2 units. And so see how we still end up having points along the same line. So either one of them is going to be a correct way to do that. So I'm going to go ahead and connect those points. And that's the equation of our line. Y is equal to -3/2 x plus 4. Now, I didn't do everything that it said here. It said graph the following lines and then label the x and the y-intercepts. So if I want to find the y-intercept for the blue line that I drew here, y is equal to 2x minus 4, we said that in order to find a y-intercept, we plug in x is equal to 0. So in this equation, if I plug in x is equal to 0, this piece is going to become 0. And then you would say -4, so y is equal to -4, which is the y-intercept. We already plotted that, so we've got our y-intercept okay. If I want, I can go ahead and label this just a little bit more, like, it's not that it's more accurate, it's just that it's a little bit more thorough. We would say that your x value is 0 and your y value is -4. So I could write the point that is actually your y-intercept. And then for my x-intercept for that same blue line, I want to plug in y is equal to 0. So if I come back over here and put a 0 in for y, what you would end up doing in order to solve for that is you would have 0 is equal to 2x minus 4. So we plugged in the 0 for the y value. You bring the 4 over to the other side. And so when you do that, you have 4 is equal to 2x. And then to solve for x, we need to go ahead and divide both sides by 2. And so the 2 divided by 2 just becomes 1x. And the 4 divided by 2 is just 2. So the x-intercept should be at 2. And then look, the way that we drew this, our x-intercept is at 2. So here's our x-axis, and our blue dot is also at 2. So if I wanted to write this as an ordered pair, I would say that this was at 2, 0. And now we want to do the same thing for our orange line. Our y-intercept, again, we already know what the y-intercept is based on the fact that that's our b value, but we could also do it by plugging in x is equal to 0 into our equation. So if you came back to our equation here and you plug in x is equal to 0, this whole piece is going to disappear and you get y is equal to +4, which is exactly what we have. So again, if I wanted to write that as an ordered pair, my x value is equal to 0 because we said plug in x is equal to 0. And my y value that pops out is +4. To find your x-intercept, you're going to go ahead and plug in y is equal to 0. So over here, if you put the 0 on this side, you're going to get 0 is equal to -3/2 x plus 4. And then in order to solve, we want to go ahead and subtract the 4 from both sides. So you have -4 is equal to -3/2 x. And so we want to get x by itself. I need to divide both sides by this -3/2. So remember, in order to divide by a fraction, that's the same thing as multiplying by the reciprocal of that fraction on both sides. So the reciprocal of -3/2 is -2/3. And I need to do that on the other side as well. So I'm multiplying both sides of the equation by the reciprocal of -3/2. We flip it over and it becomes -2/3. So this is going to become 6/6, which is just 1x. So we did that on purpose. We wanted to just get x by itself, and we did. And then over on this side, if it helps to do your multiplication, you can make it -4/1. This is going to become -2 times -4 is +8/3. So your x-intercept is 8/3, and you can go ahead and leave it as 8/3. You don't have to write it as 2 2/3. When you're in calculus classes, mixed fractions are totally fine. So you can see that it's a little bit more like ambiguous by looking at this graph. If I said, hey, where is that line, the orange line crossing on the x-axis? If you had to just look at it or eyeball it, you can't really tell. But by doing this actual calculation, we figured out, oh, that x-intercept is at 8/3. So if I want to write the ordered pair for that x-intercept, I know that it's at 8/3, comma 0, and the 0 goes in there because our y is equal to 0 whenever we're finding the x-intercept. Okay, so quick review of how to graph our lines. And so steps that you want to remember to graph a line. First thing you want to do is plot the y-intercept. And then you want to use the slope to plot a second line, or sorry, a second point. Or a third point or a fourth point, you can go ahead and do as many points as you want. And then the third step is to connect those points. All right, I'm going to go ahead and pause there and let you catch up with your notes, and then we'll get started again. Okay. So the next thing that we're going to look at is how to find the equation of a line passing through 2 points. And so we've got the points here, -3, +1, and +4, +5. And you might remember, if you were in the Math D class with me, that we used a formula, y⁻² minus y⁻1 divided by x⁻² minus x⁻1, in order to find the slope of a line if we're given 2 points that are on that line. And so what those y2s, y1s, x2, x1s really mean is they're just ways that we're labeling the points. So like if I say, hey, that's point number 1, then I would want to say, okay, well, this is my first X value. So I'm going to call it X of 1. And then my Y value for the first point, I'm going to call Y sub 1. And then if I say, hey, that's my second point, then I would go ahead and call this one X sub 2, and then call this one my Y sub 2. So it's just a way of labeling the 2 points. And you could have labeled this first point X sub 2, Y sub 2, and then called this one X sub 1, Y sub 1. That part doesn't matter. When we go ahead and plug it into the formula, we just want to make sure that we're careful. And if it says Y sub 2, I'm going to come over here. Y sub 2 is 5 minus Y sub 1. Okay, well, my Y sub 1 is positive 1. And then we're going to divide that by X sub 2 is 4. And then the formula has a minus sign, and the X sub 1 that I'm plugging in is a negative number. So we have to be careful there and make sure that I don't drop that negative sign on my actual value. So we need the minus sign from the formula, and we need the minus sign from the number. So in the numerator, we have 5 minus 1, which is just 4. And in the bottom, our denominator, you have 4 minus a negative 3. And when you have two negative signs right next to each other, that becomes a positive. So this is going to become 4 plus 3, which is 7. So the slope of this line that's passing between these 2 points is 4/7. In order to write our equation of a line in slope-intercept form, which was y is equal to mx plus b, we always had the y remaining in the equation and the x remaining in the equation, but we didn't actually have an m anymore. We'd go ahead and put whatever the slope is. And so we just found our slope. We said that it's 4/7. So I could go ahead and put the 4/7 there right now. Y is equal to 4/7 x. But then I have the plus b, and that's the y-intercept, and I don't have that yet. That's the thing that I'm going to go find now. So I still don't know what this is. I need to go find the b. And in order to do that, the only way that you can find a variable is if you have a value for all of the other variables in the equation, then you can solve for one missing variable, but I have 3 missing variables right now. And so the way that I can fix that is I need an x value and I need a y value. But if I look back up here, I actually have 2 choices. I have an x value and a y value right here, and I have an x value and a y value right here. So I can use either one of them. Either one will give me the correct answer. So you can kind of just see, is there like one that you like better? Like maybe you don't like this negative sign on this one. So you just want to use this point because they're positive. It's up to you. So I'll go ahead and do that. I'll use these ones because they're positive. So this is my y value, the 5. So where I see y right here, I need to put the 5. We still have our slope of 4/7. And then we're multiplying. If you have those things right next to each other, this means multiply. We need to multiply it by our x value. And since we're using this positive point over here, the x value is the 4. And if it helps, write it as 4/1 because you're going to be multiplying those fractions together. And then I'm still going to write plus b because I don't know what that y-intercept is. That's what we're going to solve for. So I can do a little simplifying now. 5 is equal to 4 times 4 is 16 over 7 times 1 is just 7 plus b. All right, so I have 5 is equal to 16/7 plus b. So in order to get that b by itself, I need to subtract 16/7 on both sides. And so this is where often students freak out because they're like, oh no, I have to deal with the fractions. Well, I need a common denominator. Right now, this has a denominator of 1 and this has a denominator of 7. So if I want this one to also have a denominator of 7, that means I need to multiply by our fancy version of 1, 7/7, that would let me have the 7 in the denominator, because then I would have 7 times 1 here. So I'm going to go ahead and rewrite this line up here. And I'm going to make it 35/7. And do you agree 35/7 is still just 5? I haven't changed anything. I just changed how I wrote it. And so then that's equal to 16/7 plus b. And now, since I have this 5 written in a form that has the same denominator as this fraction, I can go ahead and do the subtracting. So I can subtract 16/7 from both sides. cancels on this side. So all I have left is B. And then over on this side, 35 minus 16 is equal to 19. And when you're subtracting fractions and you have a common denominator, you just go ahead and leave that common denominator. So we just found that our y-intercept for the line that we're looking for is 19/7. And we can leave it as 19/7. You don't have to turn it into 2 5/7. In calculus, we like to keep our mixed fractions there. So in order to write the equation of a line in slope-intercept form, we said we need to have a value for m and we need to have a value for b. Well, we have our m, we figured that out first, that was 4/7. And now we have our b, we just figured that out, it's 19/7. So I can go ahead and write my equation of the line. Y is equal to, for the m, I'm going to plug in 4/7. I'm going to keep the x there. And then plus, now I'm going to plug in the b, 19/7. Okay. And so that's our answer for this one. All right. So some notes about the slope. If two lines are parallel, so parallel lines are lines that look sort of like that. We would say that these lines are parallel because they have the same slope. So if two lines are parallel, their slopes are equal. And so an example of parallel lines then would be y is equal to 2x plus 5 and y is equal to 2x minus 18. These are examples of parallel lines because the slope for this one is 2 and the slope for this one is also 2. In order for lines to be parallel, they have to have exactly the same slope. If two lines are perpendicular, so perpendicular is that those lines are going to meet at 90-degree angles to each other. Their slopes are negative reciprocals or opposite reciprocals. Okay, so a reciprocal is when you flip a fraction over. So negative reciprocals mean if the one that you're starting with is positive, then you're going to flip that fraction over and make it negative. If the one that you're starting with is negative, then you're going to flip that fraction over and make it positive. So an example of perpendicular lines would be something like y is equal to negative 3/2 x plus 1. And y is equal to, now in order to have negative reciprocals, I need to flip the fraction over. And since this one was negative, this one's going to be positive. So it's going to be positive 2/3 x. And then whatever the y-intercept is, doesn't really matter. I just need the slopes to be negative reciprocals of each other. So these are equations that are perpendicular lines. The equation y is equal to c and the equation x is equal to c, where that c is a constant, and by constant I mean just a number. So like y is equal to 2 or x is equal to 7. Those would be examples of constants. They're going to give us a special type of line. So if you have the equation of a line that starts with a y and then the other thing is just a number, so something like y is equal to 2. This is an example of a horizontal line. And this is sort of the thing that a lot of students forget when they're like, oh shoot, I can't remember if this one's supposed to be horizontal or vertical. Here's how you're going to remember that. Y needs to be equal to 2 for any of the points that are on your horizontal line. So what you could do if you forgot if it was supposed to be horizontal or vertical is just come up with 2 points. Where both of them have the y value equal to 2. So this one has a y value equal to 2, and this one has a y value equal to 2. And so I can plug in whatever I want for the other parts. I could say 1, 2, and I could say 4, 2. These would be points that are on the line y is equal to 2 because their y value is equal to 2. And so if I went ahead and plotted those points on a coordinate plane, that would help me figure out if it was supposed to be horizontal or vertical. So if I came over to 1 and then went up to 2 and put down my first point, here's my 1, 2, and then go over to 4 and up to 2. Now I can see that if I connect those 2 points, I have a horizontal line. So if you forget, you can go ahead and get it back by coming up with 2 points that are actually on this line. So similarly, if I have the equation x is equal to some constant, so let's say something like x is equal to -3. This is going to be a vertical line. And if you forget that, you can use the same trick that we just did by choosing any 2 points that are actually going to be on that line. And so points that are on that line have to have an x value of -3. And so the x is always the thing before the comma. So for both of the points, the x value has to be -3. And then the y value you can pick. So I could say -3, 0. I could say -3, 2. Those will both be points on this line. And so then if I went ahead and made a coordinate plane, what I'm going to do then is go ahead and come backwards to -3. And then I'm going to have my first point at -3, 0, which is right here. And then the other point is -3, 2. So I need to go up to 2. And so I can see now if I connect those 2 points, that this one's going to give me a vertical line. So those are kind of tricks to get those back. Now, when people are trying to figure out what slopes are for these particular lines, a horizontal line runs from left to right, but it doesn't rise. So if I want to go from 1, 2, which is this point right here, over to this point, 4, 2, and if I was like, hey, I need to do rise over run. Well, I'm not rising to get over here. I'm only running. So that means that my rise is 0 and my run in this particular case would be 3. So I went from 1 to 4 in the x direction. And so that's how I got the 3 value. But in the y direction, I was at 2 and I remained at 2. And so in the top, I didn't rise. And so if 0 is in the top of your fraction, that fraction just equals 0. So that means that horizontal lines have a slope of 0. So I'm going to just go ahead and put m is equal to 0. Okay. And then if I want the slope for our vertical line here, x is equal to -3. Well, in this case, when you go ahead and do your rise, here I went from 0 up to 2. So I rose 2. But in terms of my run, I didn't go left or right to go from this point to this point. So that means that my run is 0. So I went up 2, but I didn't go left or right. And so this means I have a 0 in the denominator. And 0 in the denominator, that's bad. So I told my last class that 0 in the top is good, 0 in the bottom is bad. And if you forget that, you can think of like what heaven and hell are supposed to be locationally. Heaven's supposed to be up, right? And so that's a good thing. So that's going to be 0. Hell is supposed to be down, low. And if it's in the bottom, that's going to be bad. That's 0. In the bottom is going to give us undefined. So you don't have to write the whole word out. Undefined is going to be the slope for a vertical line. I'm going to go ahead and pause for a moment, let you catch up with your notes. Now we're going to switch gears over to parabolas. And so there's two common forms for the equation of a parabola. First one, y is equal to ax squared plus bx plus c. This is often the form that we'll see our equation for a parabola in, because it lets us identify the a, the b, and the c that we use in the quadratic formula. And if you don't remember what that is, we'll review that in a little bit, but that's kind of the typical or the standard form that we see our parabolas in. The second equation that we'll have for a parabola is called the vertex form. And it's useful when you're just trying to locate the vertex for a parabola. So here's what that form looks like. Y is equal to a times the quantity x minus h squared plus k. And when your parabola is written in this form, the vertex of the parabola is at the point h comma. And so there's the h value and there's the k value that make up the vertex. Okay. The graph of the most standard parabola, y is equal to x squared, looks like this. And it has its vertex at 0, 0. And then if you plug in the value 1, x is equal to 1, 1 squared would pop a 1 out over here. And if you plug in the value -1 times -1 would also pop out the value 1. So you'll see that when you have a parabola, at each of the heights or y values, you end up having a mirror image point on the other side of your line of symmetry. And since our vertex is 0, 0, our line of symmetry for this parabola is the y-axis. Some notes about the letter A in both of these forms. The A is important because it tells us which direction the parabola is facing. So if the A value for your parabola is positive, the parabola is upward. And what I mean by upward is it opens like this. And if the A value is negative, the parabola is downward. Meaning that it flips upside down. And now the vertex is a maximum point. And so what's important about vertexes for a parabola is that if it's our lowest point on the parabola, we call it a min or a minimum value. And if it's the highest point, meaning that it's a downward facing parabola, then it's a maximum value or a max. And so the vertex is a very important point for parabolas and comes into play in calculus a lot. What we're going to do is use this information now, along with some other tricks, to help us graph a parabola. And so we have a parabola here, y is equal to x squared minus 2x minus 8. And we're going to follow some steps in order to graph a parabola that's written in this form. So in order to graph a parabola, we need some information. We need the vertex for the parabola because that's our most important point. So we're going to find the vertex. And specifically, we're going to find the vertex x coordinate using negative b over 2a. And the b and the a, that's coming from our values like we had in the standard form that we were just looking at. So when I'm looking at this equation up here, have an A, I have a B, and I have a C that I need to identify. The A is always the number that's in front of the x squared term or the squared term. So I can't see anything there. That means it's an invisible 1. The B is always the thing that's just in front of the x term. And so in this case, we have a -2. So we need to include the sign. And then the C is always our constant, which is convenient that the letter C goes along with constant. Constant is the number that doesn't have any variables on it. So at the end here, we've got the constant -8. So again, the signs matter for this. And so to find the vertex x coordinate, we're going to do -b over 2 times this A value. So x coordinate of vertex -b over 2a. For this parabola, -b is going to be a -2. So I need the negative sign from the formula, and then the b value itself is also negative. So I've got 2 negatives there, which is going to make it a +2. And then in the bottom, I have 2 times our A value, and our A value is just 1. So the x coordinate of our vertex is going to be +2 over +2, which simplifies to just 1. And so when we're talking about a vertex is a point. And so far, what I have for the vertex, I have this coordinate, and we just figured out that it's a 1. I still need the y coordinate of the vertex to actually find what the vertex is. And so the way that we do that is we plug the x coordinate back into our equation for the parabola. So we're going to plug in our x value right here and our x value right here into the equation, and we're going to see what pops out for that y. So the next thing we're going to do is plug in x coordinate to find the y coordinate. Okay, so my x coordinate, I'll go ahead and label that x, is 1. So in our equation, we have y is equal to x squared minus 2 times our x value minus 8. And so I'm going to plug in this 1 right here and right here. And that's going to tell us what pops out for the y value. So I have 1 squared, that's just 1, minus 2 times 1, it's just -2, and then minus 8 more. So 1 minus 2 is -1, minus 8 more would be -9. So the y coordinate that's going to pop out is -9. All right, so we have our vertex now. I know that my vertex is at 1, -9. And so if I want, I can go ahead and actually put that on my graph already. I've got my vertex, 1, and -9 is actually off the graph here, so I have to extend that line a little bit here. And we'll say that's our -9. So I'm going to come to 1, -9, and put down my vertex. All right. So that was the first step to finding a parabola. We needed to find the vertex. Second thing we want to do is find the x-intercepts. Okay, so x-intercepts, that's where it's crossing on the x-axis. And we talked about this with lines. In order to find x-intercepts for a line, we needed to plug in the y value of 0. And so the same thing is going to happen here. We need our y value for our equation of the parabola. So this y value right here needs to be set equal to 0. We're going to solve for those x values. So in order to find the x-intercepts, we're going to go ahead and plug in 0 for the y value. So 0 is equal to x squared minus 2x minus 8. So I'm writing the equation of that parabola again, but instead of writing the y, I'm putting a 0 there. That's how you find x-intercepts. And so this should look vaguely familiar when we were doing factoring before. So thinking back to how we would find factors with a quadratic. If it was factorable, we used our x box method. And so we would take our a value, which is 1, and multiply it by our c value, which was -8. So 1 times -8 goes at the top. And then the b value, which is -2, goes at the bottom. And so you're looking for two numbers that multiply to give you -8 that add up to -2. And so to multiply to give us -8 and adding up to -2, we could say we have -4 and +2, because -4 times 2 is -8, and -4 plus 2 is -2. And so we will go ahead and say 0 is equal to, and then set up our 2 sets of parentheses. And so because the value is going to be an x value here, we're going to go ahead and put -4 in one set of parentheses and then +2 in the other set of parentheses. And we're saying that this times this is equal to 0. And so in order for that to be the case, either this piece needs to equal 0. So that would be if x minus 4 is equal to 0. Or this piece needs to equal 0, which would be x plus 2 is equal to 0. And so we go ahead and solve those, and it just ends up being the opposite of what we're seeing here. If I go ahead and solve, I'm adding 4 to both sides, which means that I get x is equal to +4. And then for this one to solve, I'm going to subtract 2 from both sides. And that's going to give me x is equal to -2. So we've got our 2 x-intercepts for our parabola. One is at 4 and one is at -2. So if I come over on my x-axis to 4, this is at 4, 0. And then my other one's at -2, so I'm going to come backwards to -2. That's at -2, 0. And so then we want to find the y-intercept. So, sorry, number 3 is find the y-intercept. And so the y-intercept is where our parabola is going to cross our up and down axis, our y-axis. And so just like when we were finding the equation of a line, we said you're going to get a y-intercept whenever the x value is equal to 0. Same thing here. When we look at our equation for the parabola, we're going to plug in 0 right here for x and 0 right here for x and see what pops out for y. And so there's kind of a secret. It's always going to end up being this c value here when we plug in 0, because if I put a 0 there, that's going to cancel out. And if I put a 0 there, that's also going to cancel out. So both of those things disappear, that one and that one. And we just have that constant value, -8. But I'll show how that looks right here. So y-intercept. You're going to get that by doing y is equal to 0 squared minus 2 times 0 minus 8. But that's just y is equal to -8. So our y-intercept for our parabola is right here at -8. And so we can say that that's at 0, -8 written as an ordered pair. So we were saying how we have symmetry around our vertex. Here's our vertex point. So if I have a point that is 1 unit to the left of my vertex over here, I also have a point 1 unit to the right of my vertex at exactly the same level because I've got symmetry. And so I can go ahead and connect those points now with our parabola shape. We've got all of our important things labeled. So we found our vertex. That's 1, -9. We found our x-intercepts by setting y equal to 0. And we got x is equal to 4 and x is equal to -2. And then we also found our y-intercept, and we did that by plugging in 0 for our x values. So if that's 0 and that's 0, then that means that y is equal to -8, which is right there. And then we went ahead and connected it with our parabola shape. Okay. We have one more page to do with our notes. Okay. And what this is going to do is combine the two things together that we were talking about. So we're going to consider these two graphs. This graph right here, y is equal to negative x squared plus 6x. That's a parabola. And I know that's a parabola because it has an x squared term in it. And this equation, y is equal to 2x plus 3, this is in y equals mx plus b form. So I know this is the equation of a line. So this says, consider this parabola and this line, find their points of intersection, or where does this line cross this parabola, if any. So does the line actually cross the parabola? And the way that we're going to look at this is we're going to consider what that would actually mean for them to intersect. For them to intersect would mean that these two equations are going to be equal to each other. So I would go ahead, this is y and this is also y. So I would go ahead and say, well, if y is equal to negative x squared plus 6x, and y is also equal to 2x plus 3, that means that these things have to be equal to each other. So I went ahead and set the two equations equal to each other because that y would have to be the same as that y. So this would have to be the same as this. So when you set them equal to each other, you can see that the biggest power we have on any of these pieces is something squared. That means we have a parabola or we have a quadratic equation. And the way that we solve quadratic equations is to get everything over to one side and set it equal to 0. So I'm going to go ahead and move this piece and move this piece over to this side. So I need to add x squared to both sides. And I need to subtract 6x from both sides. Okay. So over here, these cancel and these cancel. So I just have 0, which is what I wanted to have happen. And then on this side, I'm looking and I go, okay, well, I have positive x squared. I have 2x's minus 6x's. So I have $2, but I owe someone $6. So if I pay them the $2, I still owe them $4. So that's going to be a minus 4x. And then I just have one constant plus 3. And so at this point, I'm hoping that I can factor this. So this would be one of your X box factoring problems. And so this is 1 times 3, that goes at the top. And then negative 4 will go at the bottom. So I need two numbers that multiply to give me positive 3, but add up to negative 4. So if I do negative 3 times negative 1, I can get positive 3. And then negative 3 plus negative 1 will give me negative 4. So I can go ahead and put my two sets of parentheses. And so this is going to be x minus 3. And then x minus 1. And so you're going to go ahead and take each of those pieces and set them equal to 0. So x minus 3 is equal to 0 and x minus 1 is equal to 0. So to solve that, you go ahead and add 3 to both sides. And you get x is equal to 3. And to solve this one, you'd add 1 to both sides. And you get x is equal to 1. And so what these are telling me is that I have an x value at 3 and an x value at 1 for my points of intersection. And so points of intersection, a point is an x value, comma, y value. X value, comma, y value. So we just found the x value for our 2 points. So this one has a 3 for the x value, and this one has a 1 for the x value. But that means I have to go find the y values. And so to do that, you're going to come back up to these equations up here and go ahead and plug in your x value. Now, you can plug in your x value to either equation. You should get the same answer regardless of which one you plug it into. So let's check that out. If I plug a 3 in right here, you have 3 squared, which is 9, but we have to pop a negative sign on it. So this becomes negative 9. And then plus 6 times 3 is 18. So we have negative 9 plus 18, which is just 9. So I got y is equal to 9 on this side. And if I take the 3 and I plug it in here, I hope I also get 9. 2 times 3 is 6, plus 3 more is 9. So it doesn't matter which one you plug it into. So because it doesn't matter, I'm going to plug it into the one that's easier to plug it into, which is going to be the equation of the line usually. So we said that when I plug in the 3 right there, 2 times 3 is 6, plus 3 more is 9. So y is equal to 2 times our x value of 3, plus 3 more. So that's 6 plus 3 more, which is 9. So 3, 9 is one of our points of intersection. And then to find the other one, I'm going to go ahead and plug the 1 in for the x right here. So again, I could plug it into the other one, but I decided that this was the easier formula. And since we'll get the same answer either way, let's plug it into this one. So y is equal to 2 times, this time we're plugging in 1 for the x value, plus 3. So that would be y is equal to 2 plus 3 more, which is 5. So we just got the 2 points of intersection, meaning that, yes, this parabola and this line intersect. So this line's going to cross this parabola at 2 different points. So we figured that out algebraically. This says go ahead and sketch a graph of both of those equations and then shade the area that's bounded by the 2 graphs. I'm going to start by graphing the line. So y is equal to 2x plus 3. If that's a line, I need the slope. The slope is 2. I'm going to go ahead and write it as 2 over 1 so I can see the rise over the run. And my b, or my y-intercept, is positive 3. And so we said in order to graph an equation of a line, you go ahead and put the y-intercept down first. So there's my y-intercept. And then you use your slope to find another point. So this says go up 2 and over to the right 1 and put another point down. And I could do this again if I want to get another point. Go up 2 and then over to the right 1. Then go ahead and connect those points. All right. And then we also want to graph the parabola. And so this parabola, y equals negative x squared plus 6x. It's technically got a plus 0 there, even though I can't see it, but that's going to help me figure out my a, my b, and my c. So the a value is always the thing that's right in front of the x squared term. So I have a negative sign with an invisible 1 there. So negative 1 is the a value. The b is always what's in front of just the x term. So we have a positive 6 there. And my constant, I wrote in a plus 0 because we can't see the constant. It's actually just 0. And so we said, in order to find our vertex, specifically the x coordinate, we do negative b over 2a. Okay, so negative b in this case is going to be negative 6. And then 2a is 2 times negative 1. So we got negative 6 divided by negative 2. It's positive 3. So our vertex is going to be a point in x comma y. We just found the x coordinate is 3. And so to get the y coordinate of the vertex, we need to go ahead and just plug it back into our equation. So I want the y. So I'm going to plug in 3 right here and 3 right here. So y is equal to negative 3 squared plus 6 times 3. And I can write plus 0, but I don't have to. So this is going to be negative 9 plus 18 plus 0. Negative 9 plus 18 is just 9. So my vertex is the point 3, 9. So if I come over to 3, and then I go up to 9, and I don't have 9 here, so I have to draw it in. 3, 9 would be right around here. And that's the vertex. Now, I know that this parabola is going to be downward facing. And the reason that I know it's a downward facing parabola is that the equation for the parabola has an a value that's a negative number. So we said if a is negative, it's going to be a downward facing parabola. So that's good news. So after we find the vertex, then we want to find our x coordinates. And so, our x-intercepts. So x-intercepts we found by setting y equal to 0. So in our equation for the parabola, which is this one right here, instead of writing y, I'm going to write 0 equals negative x squared plus 6x. I'm not going to write the plus 0 because we don't need it. In order to solve this one, to factor this one, we don't actually need to make an x. We just need to factor out the greatest common factor, which is just an x. So if I plug, I'm going to go ahead and actually pull out a negative x. If I pull out a negative x, in order to get negative x squared, I would have to multiply by another x. And then if I have a negative x pulled out, in order to get a plus 6x, I would have to multiply by a negative 6. So check that out. Negative x times negative 6 would give us positive 6x. So this is the factored form. And so that means that negative x is equal to 0. And x minus 6, I also need to set equal to 0. And so if negative x is equal to 0, well, in order for that to be true, this x value has to be 0. And then this one, if I add 6 to both sides, I get x is equal to positive 6. So I have two x-intercepts for this parabola, 0 and 6. So here's x equals 0. And here's x equals 6. And so then the last thing we wanted to find is our y-intercept. And remember, the y-intercept, I said one trick that you could use is that it's always going to be the c value when it's written in the y equals ax squared plus bx plus c form. Well, our c value is 0. Or you could go ahead and plug in the 0 for the x. So if you plug in y equals 0 squared, and it's a negative 0 squared, plus 6 times 0 plus 0. Well, that's 0, because this is 0 plus that 0 plus another 0 is 0. So the y-intercept for this parabola is also 0. So we didn't get any additional points out of that. So when I go ahead and connect my points here, this one's going to come down, and we said that it's going to, where our intersection points are going to be at 3, 9 and 1, 5. Well, 1, 5 is right here. So that means that this parabola is going to go through that point, and then it's going to cross right there. And then 1, 5 is another place. Sorry, 3, 9. That's the other one. 3, 9. Right here. Well, that's where the orange line is hitting that parabola. So that is true. And then we go ahead and connect that. I didn't quite hit that point very well. Okay. And then it says shade the area bound between the two graphs. And so this is something that you do in calculus a lot, where they'll say, hey, find the area that's between the two graphs. That's what it means to be bounded. So between these two graphs is this little sliver right here. That's my shaded area between the two graphs. All right, nicely done on your first set of notes. We'll have some problem solving to do together.